Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be solving this problem to find the first few terms of the series expansion of square root of 1 minus x divided by 1 plus 1 over x. Okay, now that is actually, it's not even a rational function possible. We have a kind of square root of 1 minus x that's transcendental, for instance, all over 1 plus 1 over 1 plus 1 over x, right? Now, you can go about it in different ways. You have square root of 1 minus x divided by 1 plus 1 over x. For instance, you can see this as 1 minus x raised to power half divided by 1 plus 1 over x, like this. And then that can become 1 minus x raised to power half into 1 plus 1 over x raised to power minus 1. So this is an approach to it. Uh, but another way to do this can just be like this. You have square roots of 1 minus x divided by 1 plus 1 over x. So we can take it further and say this is, in fact, we're not even doing the expansion yet. We're just trying to tidy things up. So you can take this as square root of 1 minus x divided by, LCM here, 1 over 1 here. So LCM of 1 and x, that will be x. So 1 in x is x, x times 1 is x, plus x in x, 1 times 1 is 1. So you can have that as, you can actually have that as square root of 1 minus x divided by 1. Okay, well, let me even elaborate it more than this. So now this is divided by x plus 1 over x. So then this is square root of 1 minus x times x over x plus 1, so that we can tidy this up to be x square root of 1 minus x divided by x plus 1. So this is basically what we have now. So here we see that square roots of 1 minus x, okay, square root of 1 minus x all over 1 plus 1 over x is the same thing as x root 1 minus x divided by 1 plus x, something like this. So now we can take the parts one after the other. So now we can say this is the same thing as x 1 minus x raised to power half being square roots, and then you have 1 plus x down there. That is 1 plus x raised to power minus 1. So we can have it that way. Now, let's take it. So of course, x is settled, but we have 1 minus x raised to power half. This is the fractional power. So we can use the general rule, which is that 1 raised to power half minus x raised to power 0 over 0 factorial, plus the half comes down. So half into 1 raised to power minus half, that's half minus 1. Then minus x raised to power 1 divided by 1 factorial plus half into minus half, then 1 raised to power minus half minus 1, that's minus 3 over 2, then minus x raised to power 2 divided by 2 factorial, and that's continuous. So we can stop with 3 terms. We just need the first few terms. So of course, 1 raised to power half is 1. 1 raised to power anything is 1 in short. So for this whole thing now, we have 1 into minus x raised to power 0 is also 1. 0 factorial is 1 plus half here. 1 raised to power minus half is 1. Then you have minus x. 1 factorial is also 1 plus half into minus half. 1 raised to power minus 3 over 2 is 1. Then minus x squared is simply x squared divided by 2 factorial is also 2. So we can have this as 1 plus okay, minus there. So we have 1 minus half x. Then we still have is that okay? Yeah, we still have minus here. So that's minus. This 2 down here can actually come as, so this is like half times half times half. That's 1 over 8 x squared. And that still continues, that's continuous. So basically this is, square root of 1 minus x is simply 1 minus half x minus 1 over 8 x squared. Okay, so that's settled. Now, let's go for the next part of it, which is 1 plus x raised to power minus 1. So 1 plus x raised to power minus 1, 1 plus x raised to power minus 1. That is equal to, again, the same formula, 1 raised to power minus 1, x raised to power 0, divided by 0 factorial plus minus 1 comes down, 1 raised to power minus 1, that's minus 2, x raised to power 1, all over 1 factorial plus minus 1 times minus 2 into 1 raised to power minus 3, that's minus 2 minus 1, then x raised to power 2 divided by 2 factorial, and all of that continues. So we have 1 raised to minus 1 is 1, x raised to power 0 is 1, 0 factorial is 1, then plus minus 1, 1 raised to power minus 2 is 1, x over 1, then here plus, this is minus 1. So we have minus 1, minus 2, 1 raised to power minus 3 is 1, then x squared divided by 2, 2 factorial is 2, plus all of that. So 2 cancels this 2 right here. So we have 1 times 1 divided by 1, that's 1, minus x. Then here, minus and minus is plus, that's plus x squared. And that goes on like that. So from here, we see that 1 over 1, 1 over 1 plus x, that is equal to 1 minus x plus x squared, and so on and so forth. So if you go back to where we started from, if you go back here, or yeah, if we go back here, so we can say now x into 1 minus x raised to power half into 1 plus x raised to power minus 1 is the same thing as x into, the first 1 minus x raised to power half. That's 1 minus half x minus, that's 1 minus half x minus 1 over 8 x squared, and all that, into 1 plus x raised to power minus 1. That's 1 minus x. That's 1 minus x plus x squared, and all of that also continues. So then we go on to say this is the same thing as, so we can do this one first. X times 1, that's x minus half x squared minus 1 over 8 x cubed. Let's forget about the continual, the other parts. Then you have 1 minus x plus x squared. So here, let's stop, since we need just the first few terms, let's stop with only powers of 3. So anything beyond powers of 3, we can forget about it. So x times 1 is x. X times minus x, that's minus x squared. X times x squared is x cubed. Okay, done. Then the next one, we have minus half x squared times 1. That's minus half x squared. Minus half x squared times x, that is times, that's minus minus, right? Yeah. So minus half x squared times minus x, that is plus half x cubed. So if we go further, we have x raised to power 4, which we don't, which as we've agreed we don't need. All right. So let's stop here. And then for the last one now, we have minus 1 over 8x cubed times 1. That's minus 1 over 8x cubed. Of course, that still continues. Okay. Okay, I can still do this. All right. So now we can take it further and say that this x into 1 minus x raised to power half into 1 plus x raised to power minus 1 is the same as, so let's put similar powers together. So for powers of 1, I think we have just x. So we have only x for powers of 1. So we have x. Then for powers of 2, to make things easier, let me just put plus here. For powers of 2, we have minus x squared minus 1 over 2 x squared. All right. What else? For power 3 now, we can say plus x cubed plus 1 over 2 x cubed minus 1 over 8 x cubed. And then all of this continues. So this is equal to x. So here we have, this is like minus 1 over 3. all of that will be minus 3 over 2x squared. Then when we come to this is like 1 plus half minus 1 over 8. Okay. So again, that is like, so this is 1x cubed plus half x cubed minus 1 over 8x cubed. The LCM there is 8. So 1 in 8 is 8 plus 2 in 8 is 4. Then minus 1. That's 11 over 8. Okay. Just like here we had minus, for this now, we had minus 1 over 1 minus 1 over 2. And that's LCM is 2. 1 and 2 is 2. That's minus 2 minus 1. That's minus 3 over 2. That's why we have this minus 3 over 2, basically. So here it means that this is actually plus 11 over 8 x cubed, and all of that continues. Okay. So that's how that is. So we have the first few terms of that expansion. So you may just want to recall what you start where you started. You can also, therefore, the first three terms are not specified, but we've got 3 terms. So the first three terms of the series expansion can be square root of 1 minus x all over 1 plus 1 over x. This is what we started with. And that is equal to x minus 3 over 2 x squared plus 11 over 8 x cubed plus all of that. Okay. Now, if you do it the first way, the first approach I explained, like if you do it this way, you most likely not get exactly that same thing, but you may get some other terms. But so if you try that way, you can get something else. And that will still be correct, right? It's all about the approach. But I mean, I chose to go this other way. All right. Maybe I should even do that other way in the next video and see how that works. Okay. All right. So you have more of this coming. So you may want to um subscribe and hit the notification bell so you don't get to miss any of these things again. And then comment, let me know how useful these videos are for you. Let me know if you like me to teach a topic or solve a problem, and like and share so that more people can have access to this. So like come your way again. Do have a great time. Bye.